So hi guys, today we're gonna take a look at two most important quantifier that you will learn in calculus with proof. So the first one is a flip A, right? So what does it mean? It means um for every or all. And the second symbol is like a backward E. So what does it mean? This symbol means? This symbol means that there exists a blah 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 blah. So how do we put this into like an example? So let's look at the first example. So we have this symbol which is indicating for every, and there's x, and there's this which is a symbol for is an element of, and this is integer. So before approaching these problems, so the question you always want to ask yourselves is how do I translate this sentence into this mathematical sentence into like an actual English sentence. So what you do is that you kind of look at it. So what is the first one translated to? So the first we have, like what I said up here, the first symbol means for every, right? So we can write for every. And the second we have x. X is an element of integer. So what this means that x is an integer. So we could write it for every integer x, because that's what it means, right? X is an element of integer. X squared is bigger than 0. So do you think this is true? Well, if you look at my previous video, that integer is whole numbers that include all positive and negative. In this case, it must be false because -1 is an integer, right? Or -2 is an integer, but it's not bigger than 0. So therefore, this statement must be false. So we look at the next sentence, right? So again, what you want to do is translate the mathematical statement into an English sentence. So let's look at it again. So what's the first symbol say again? It says for every. X is an element of real number. So for every real number x, that's what I say. X squared must be bigger than 0. Think about this. Do you think this is true or false? Well, this is true, right? Because think of any number like -3, right? -3 squared is 9, or 2. 2 squared is 4. So every real number, negative or positive, their square must be a positive number, right? So therefore, this statement is true. Well, there are some special circumstances where s square might be negative, but that's not part of a real number. That will be like a imaginary number, which you will learn in higher and more advanced mathematics, which I'm not going to discuss here. So let's look at an example. So we have this symbol. So let's recall what does this symbol means. This symbol means there exists a. So it's the same thing. Look at this. So there exists a. X is an element of real number. So there exists a real number x such that x squared is equal to 9. Such that x squared is equal to 9. Is this true? Well, this is true, right? Like 3. Like if x squared is 9, then x will be square root of 9, which x will be 3. So right, so there truly exists a real number x such that x squared is equal to 9, and this real number is 3, right? So 3 is a real number, so this statement must be true. So let's look at the next one. Again, translate into an English sentence. So again, start with there exists a. X is an element of real number. So we say there exists a real number x such that x squared is equal to -9. So is this true or false? Well, like our second example, this must be false, right? So there's no real number. Let's use example. Let's say real number 5, right? 5 is a real number. 5 squared is 25. Or -10. -10 is a real number. -10 squared is 100. So there's no real number There's not a single real number where you can square it and it can be like a negative number. So this statement must be false, because what this statement is saying is that there exists a real number, which if you square it, you get the -9, which is not possible, because no matter what the real number is, if you square it, like I said in the second example, it must be positive. So therefore, this statement must be true, because the statement is saying that there exists a real number, that you square it is negative, which is false. So these will be our 4 little example to get you more familiar with this kind of quantifier ideas, which will be extremely important in later comes in proof and all that. So thanks for watching.